Friends, welcome to my YouTube channel. Dhanesh here. In the last video, we were discussing with chi-square test. In this video, I am going to discuss about z-test. Let's start. This is a very nice quote from Sir Isaac Newton. If I have seen further than others, it's by standing upon the shoulders of giants. Fine, let's continue with z-test. Before getting into z-test, I want to give you some idea about exploratory data analysis, that is EDA. You are familiar with exploratory data analysis. If you want to learn EDA, there is a separate playlist for EDA. There I have given videos for univariant analysis, bivariant analysis, multivariant analysis. In bivariant analysis, there are two variables will come into picture. If both the variables are numerical, you will go for correlation coefficient. If both are categorical, you will go for chi-square test. If one is numerical and another one is categorical, you will go for t-test, c-test or ANOVA. In this video, our focus is on z-test. A z-test is a statistical test to determine whether two population means are different when the variance are known and the sample size is large. Very important. When the sample size is large, we will go for z-test. It can be used to test hypothesis in which the z-test follows a normal distribution. Very important. If the if the distribution that should be normal distribution. Normal distribution is also known as Gaussian distribution. It's also known as bell curve. You are familiar. Bell curve means the shape of the bell curve. The distribution is like this. This is normal distribution. Then only we can go for z-test. A z-statistics or z-score is a number representing the result from the z-test. Fine. You got it. Now, next we are going to discuss about the characteristics of z-test. It can be used to test hypothesis in which the z-test follows a normal distribution. We already discussed. A z-statistics or z-score is a number representing the result from the z-test, the final result that we will come to know in the math behind z-test. In the video we will discuss. That is known as the z-score. And even there is a separate video on z-score, IQR score. IQR means interquartile range, so you can watch those videos as well. Here we will just discuss the math of z-test. See, a z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large. All these aspects we discussed. These are all the characteristics. I am giving one more. See, both z-test, t-test and ANOVA test are using when one variable is categorical and another one is continuous. We discuss. So what's the difference? Because both z-test and t-test are somewhat similar. So what difference it make between z-test and t-test? Z-test works for sample size greater than 30. Very good. Very important. Z-test works for sample size greater than 30. T-tests are best performed when an experiment has a small sample size. Then you will go for t-test. C-test assumes the standard deviation is known. Then only you can go for z-test. T-test assumes that the standard deviation sigma is not known, is unknown. Fine. Let's discuss an example, then you will get more clarity on this z-test. The obesity in children. So we need to get into this example. We need to study the obesity in children in a city. That's a 15-year-old kids in the city. Whether those kids are obese or not, we need to analyze. The average weight of a 15-year-old is 55 kg. That's not. The average weight of a 15-year-old kid is 55 kg with a standard deviation of 10. This is the result of the population. This is the what is the difference between population and sample. You need to understand that. We have the videos, you can watch it in the playlist statistics. A sample of 100 kids we have taken where the selected 100 kids were selected and the average is found to be 58 kg. Then their average is 58. We need to check whether these kids are obese or not for a significance level of 0.05. What is significant level? It's denoted by the letter alpha, and its most optimal value we use in statistics is 0.05 or 5%. Please learn significance level, p-value. We have all these videos in the playlist statistics. They are very important. Please watch and learn those concepts: p-value, significance level, z-score, iqr score. Okay, fine. See, we will get into the this example. We will so first we need to define the null hypothesis and alternate hypothesis. You need to understand these two terms. Then what is null hypothesis? Our null hypothesis is for mu is equal to 55, the children in the city are not obese. Because the average value it's given, it is 55. This is the, for the population it is 55. So we are defining for mu for null hypothesis, for an average of 55, the children in the city are not obese. Then the alternate hypothesis is, if mu is greater than 55, the children are obese. This is our alternate hypothesis. Let's analyze it. For that, you need to understand the math of z-test. The math, it is x bar minus mu 0 divided by sigma divided by root n. What is x bar? Sample mean. Very simple. What is mu 0? Population mean. What is n? Number of samples. What is sigma? Standard deviation. This is the formula. So we need to apply. See what is here. In this formula, what is x bar here? X bar is 58. It is the sample mean. In the formula, x bar is 58. So 58 minus, what is the population mean? It is 55. Divided by, what is the standard deviation? I think it is 10, right? Divided by what is the number of samples we have taken? You can see here it is 100 kids we have taken. So its root of 100 is 10. Then 10 by 10 it is 1. So 58 minus 55, it is 3. 3 is the answer. That's what it's given here. Math of c-test, it's 58 minus 50, that is 3. So now we need to understand this is the normal distribution, z values for the normal distribution. So from this z values, we need to get the p value. See here, these values, it's given here is the z value. This is also c value. You can, from the table itself, you can. So what is these values? This is the p value, probability value. We have videos for p value, significance level, alpha, everything is there. You need to learn it to understand it more clearly. So this is the p value. So we are calculating the p value for our z value. What is our z value? 3. So the corresponding p value is 0.9987. 0.9987. If you have a your z value is somewhere around 3.1 or something, then you will get like this, or 3.009 or something, you will get into 3, then this 0.09, you will get into this value. You are getting me? So that's at 0.0001, like that it's given. So our value is 3. So our value is 0.9. This is the p value. See, this is the z value it's given here, and all these values are p value. This is p value. So we got the p value for 3. It is 0.9987. See, you need to understand. Now I am giving some more clarity about the p value and the significance level. We have the significance level, it's already we discussed. We are taking it as 0.05. Now we got the p value and the significance level. What is our p value from the table? It is 0.9987 and a significant level of 0.05. So these two data, based on these two data only, we are checking whether we need to go for the alternate hypothesis or null hypothesis. This is very important. Based on the p value and alpha, these two values are very crucial. Based on the p value, that is the probability value, and alpha, the significance level, based on that we will take whether we should go for the null hypothesis or alternate hypothesis. See, I am giving some more idea about if the this is the theory behind that, the p value versus significance level. If the p value is greater than alpha, you assume that the null hypothesis is true. Very important. If the p value is less than alpha, you assume that the null hypothesis is false, and you should go for the alternate hypothesis. What do you do if the two values are very close? Then you will collect more data, then again you will do the experiment again. That's what you have to do. Anyway, see, we need to check our p value is greater than alpha or not. See, what is our p value? Our p value here, it is I told you it is 0.9987. This is greater, this value is greater than the significant level, so this is bigger one. 0.9987 is greater than, here our final conclusion, 0.9987 is greater than 0.05. That is, our p value is greater than the significance level alpha. Based on these two parameters only, we will conclude whether we will go for with the null hypothesis or alternate hypothesis. Here the p value is greater than the significance level, and the null hypothesis is true. What is the null hypothesis? The children in the city are not obese. Fine. So that's the conclusion. So that's all about z-test. Thanks for watching. Please like, share and subscribe. Thanks a lot.